Welcome to ShapeMakers, the podcast series from the Aluminum Extruders Council. AEC is a trade organization representing over 75% of the aluminum extrusion production in North America. In this series, you'll hear about key issues that affect both extruders and suppliers in the industry, as well as those who specify and use aluminum extruded products. Our guest speakers will discuss in-depth topics like aluminum extrusion, fair trade cases, what the industry is doing to attract and retain skilled workers, how extrusion products are rising to the challenge of stricter building and energy codes, the rise of extrusion use in vehicles, and much more. So sit back, relax, get comfortable, and get ready to learn more about aluminum extrusion.
Hi. Today we'd like to talk a little bit about aluminum extrusion and the circular economy. I'm Lynn Brown, a consultant to AEC and a leader of the Council's sustainability initiatives. I'm joined by Rue Rogers, Marketing and Sales Manager of AEC member Tower Extrusions, a major U.S. extruder. Rue, could you tell our listeners a bit about Tower?
Absolutely. As you said, Tower is a major U.S. extruder. We have 4 facilities, 3 in Texas and 1 in Puerto Rico. We operate 13 presses ranging from billet size of 6 inches up to 12 inches. In addition, we have anodizing, painting, and fabricating operations. We have our own cast house where we process scrap and prime to cast aluminum billet, the raw material for our presses. Our market focus is on the building and construction and transportation markets.
So what's behind your interest in the circular economy?
Well, I'm co-chair of the AEC's building and construction team and active on the sustainability team. So it's kind of a natural fit.
So I'm guessing you're familiar with the concept of circular economy, but that may be a less familiar term for some of our listeners. So let me start with a definition, make sure we're all on the same page. And I'm going to reference the Ellen MacArthur Foundation, which is a leading nonprofit who's been focused on the circular economy for almost 15 years. And they define the circular economy as a system where materials never become waste and nature is regenerated. In a circular economy, products and materials are kept in circulation through processes like maintenance, reuse, refurbishment, remanufacture, recycling, and composting. The U.S. Environmental Protection Agency also says, and they cite the foundation, they add that a circular economy keeps materials in products in circulation for as long as possible. Further, they note that work on a circular economy is an important part of slowing climate change. And the EPA cites the United Nations International Research Panel's conclusion that natural resource extraction and processing, which of course is where aluminum extrusions ultimately come from, contribute to about half of all global greenhouse emissions. So, Rue, what resonates with you regarding extrusions in the circular economy?
There are a couple phrases in those definitions, Lynn, that resonate. The EPA says something about keeping materials and products in circulation as long as possible. And the MacArthur Foundation definition mentions maintenance, remanufacture, and recycling. Those all tie together. And as it seems that maintenance, remanufacture, and recycling are key to keeping material in circulation.
Can you say a little bit more about that?
Sure. Well, aluminum has a history of being kept in circulation. Due to recycling, the International Aluminum Institute estimates that 75% of all of the aluminum ever produced is still in use today. That's 75% of all aluminum produced since 1888, over 135 years. They also estimate that over 35 million tons of aluminum is recycled each year.
Well, let's talk more about recycling, because that seems to be key to that 75% statistic and keeping the metal from ever ending up in landfills or as scrap. You mentioned that Tower operates a cast house or a remelt facility where you cast aluminum billet from scrap, as well as some primary or virgin aluminum. How does that work?
Well, basically, there are 4 steps. First is the collecting of the right raw materials, the virgin aluminum and the aluminum scrap. Second is the melting of those materials together. And the third is the filtering the melt and pouring it into the molds, typically 24-foot long. And at Tower, we cast 6, 7, 8, 9, 10, and 12-inch diameters, and then you let the logs solidify. The final step is the homogenizing of the logs, which is heating them into an oven or in an oven up to about 1050 to 1060 degrees Fahrenheit to get the correct and uniform grain structure.
So you mentioned that you're melting both raw or both virgin aluminum and aluminum scrap. What would the typical mix be between that virgin metal and scrap?
Sure. We usually run between 25 to 26% virgin aluminum and 74 to 75% scrap. According to the extrusion industry EPD that the AEC conducted back in 2022, North American extruders typically use about 53% scrap and 47% prime or virgin on average.
Okay. Let's talk about the scrap, because you guys are just about 3/4 scrap in what you're casting, and that really seems like it's the key to keep aluminum, that aluminum that was produced decades ago, in useful applications. Where does that scrap come from? What kinds of scrap are you talking about?
Yep. Well, think of scrap in 2 buckets. The first one is the pre-consumer scrap, which is generated in the extrusion or product manufacturing process, and post-consumer scrap, which comes from products at the end of the life cycle. So we will generate a lot of pre-consumer scrap in our extrusion operations, which will consist of billet ends, cutoffs when we clamp and stretch the extrusions, or just typical damage throughout the process. On average, North American extruders will produce about 80% sellable extrusions on a per pound basis and 20% internal process pre-consumer scrap. So then we also get pre-consumer scrap from our customers, leftovers from when they cut, or chips from their machining, damage, etc. So any parts of the extrusions that they buy that are excess or that they can't use, we can use that and recycle it.
Well, what about that second bucket, the post-consumer scrap? What are you talking about there?
So that's something that we'll buy from scrap dealers: truck wheels, wire and cable, parts from building demolitions or upgrades. For instance, parts from old windows and doors. Those are all good sources of post-consumer scrap.
What about aluminum cans? Because there's certainly a lot of those out there. There's a big push to recycle those.
No cans, no cans. Those are really a different alloy, and they get quickly snapped up to be recycled into can sheet and turned into new cans, actually. And according to Can Pack, an aluminum can be back on the grocery shelf in as little as 60 days after its contents were consumed.
That 60-day turnaround is pretty crazy. That's impressive.
Incredible.
What about, I know a lot of extrusion is either painted or anodized. Can you recycle that post-consumer scrap as well?
Well, anodized extrusions are treated just like any unfinished extrusion when it comes to recycling. That's because the anodized coating is generated from the base aluminum metal and has the same constituents as the aluminum. But the painted extrusions are a bit different due to the addition of the paint, which give off VOCs when the extrusion is heated to the melting point. So you can still recycle painted extrusions, but the total quantity may be limited by the air treatment equipment and the emissions permits for your particular cast house.
Okay. So all that scrap, included painted and extruded extrusions, but no cans, just goes into a furnace, gets melted.
Well, not quite. We sort the scrap by alloy using scanners or chemical tests, and then we add the alloy mix we need to get our planned alloy, along with the primary and often with some additional alloying materials, magnesium, for example. It's all about getting the right chemistry for the desired alloy of the billet.
Okay, so that billet that you precast can be used just like a billet of primary or virgin aluminum. It doesn't have to be downgraded to lower performance applications because of the scrap content.
No, that's the beauty of aluminum. It can be recycled over and over without any degradation in its properties. So we can use that billet with the high recycled content to make new parts for commercial windows or trailers or solar panel frames or whatever the customer may desire.
That's a big difference from a lot of other materials that do get downgraded in recycling. Ruth, that's really helpful, talking us through the recycling process and giving our listeners an understanding of the reality of that at the plant level. Let's step back a little bit to the extrusion industry level. How does this all work at the national level?
Well, we believe it works quite well, actually. So let's think back to 2021. That's the year, that's the base for the EPD that I mentioned a moment ago. In 2021, the 200 or so extrusion plants in the United States and Canada used over 7.5 billion pounds of billet. About 3.7 billion of that was virgin material, leaving just under 4 billion pounds of scrap. That scrap was collected by a wide network of brokers and processed through over 40 cast houses around the country. We estimate that the scrap included about 1.1 billion pounds of post-consumer scrap, with the remaining 2.8 billion pound pre-consumer or industrial scrap. So this is all working all over North America and represents well over half of the raw material required by the industry.
Great story. Why does this work so well? And could more scrap be utilized?
I think there are three reasons why it works so well. The first is that the scrap does not have to be downcycled. Like I said, it retains the same properties as virgin material and can be used for almost all the same applications. Point number two, aluminum scrap has real value. In 2024, virgin material has been selling for $1.15 to $1.35 roughly per pound in the United States. A cast house may pay between $1 to $1.25 per scrap, depending on alloy and cleanliness. That makes it worthwhile to collect and sell it. Which takes me to the third point. There is a well-established infrastructure across the country of scrap dealers who do just that. They collect, they sort, and they sell. And yes, more scrap could be used. We think we do a very good job of capturing pre-consumer scrap, but there's an opportunity to use more post-consumer. The challenge there is sorting bits of steel or other materials out of the scrap mix, and the industry is actually hard at work developing better approaches to do just that.
Well, that's a great story. Let me go back to where we started, which was the definition of a circular economy from the MacArthur Foundation. Products and materials kept in circulation through processes like maintenance, reuse, refurbishment, remanufacture, recycling, and composting. Obviously, extrusions don't get composted, but they certainly are kept in circulation, as you point out, with 75% of all that aluminum that's ever been produced still in use, though most likely in a different form, thanks to recycling. I guess today's automotive bumper beam may have started out as a commercial window frame in the 1960s. We also know that extrusion's corrosion resistance gives them a really long life with minimal maintenance as compared to other materials. There's certainly extrusion in commercial buildings that have been there for over 50 years. So it seems like aluminum extrusions are really a great example of the circular economy.
Absolutely. And that's a reflection of the fact that recycled materials do not have to be downgraded, so it has substantial value, which has led to the robust North American network to collect, process, remelt, and reuse the scrap.
Ruth, thanks so much for sharing your thoughts on this topic with us.
Thank you, Lynn. Appreciate you for having me.